Hello, my name is Doyle Motz. I am a research engineer and the Nondestructive Evaluation Division Director for Texas Research Institute, Austin. I am the principal investigator for SBIR topic N211-062, titled Non-Destructive Detection of Flaws Through Thick Polymers Using Electromagnetic Imaging Technologies. Texas Research Institute is a small business located outside of Austin, Texas, specializing in engineering projects, polymer material science and development, and non-destructive evaluation, otherwise known as NDE research. Today I am going to be discussing the technology developed to successfully achieve the goals of the Small Business Innovative Research Project, topic N211-062, fabrication and demonstration of an electromagnetic imaging system for the inspection of metal substrates under thick polymer coatings. First, the project we're discussing involved examining for the bond line health underneath a very thick polymer coating on the order of many inches. This type of inspection, with a very large amount of standoff from the substrate and the naval environment that it needs to be conducted in, does not lend itself immediately to any of the traditional non-destructive evaluation technologies such as ultrasound, eddy current, X-ray, or others. However, electromagnetic or EM energy in the microwave frequency band on the order of 300 MHz to approximately 40 GHz, or put another way, a wavelength of about 1 meter to 7 millimeters is capable of penetrating these thick coatings and providing a balance between penetration depth and defect detectability. Techniques using microwaves provide a wide range of solutions for imaging through both thick and thin coatings and multi-layered structures. Solutions utilizing near-field techniques can provide sub-wavelength resolution of anomalies, inspecting through dielectric coatings and on the surfaces of the substrate to which it is adhered. Techniques in the far field, commonly utilizing a lens antenna, provide resolution on the order of 1 to 2 wavelengths, but allow for the inspection to be done from a greater distance to the target, something on the order of tens of wavelengths than near-field techniques. Synthetic aperture radar, or SAR techniques, can merge these two inspection technologies and provide for sub-wavelength resolution both near and far field inspection setups. SAR imaging algorithms create a very large synthetic aperture out of a small physical aperture via the physical motion of the physical aperture. This type of imaging has been used for a number of inspections and imaging projects, one of the most esoteric being in the last several years to image the black holes at the center of the Milky Way and M87 galaxies. The measurement locations are chosen to ensure that the inspection target is always in the near field, thus providing sub-wavelength resolution and high sensitivity to any potential flaws regardless of the distance. The actual microwave antenna SAR imaging technologies have been tested, fabricated, and delivered as inspection systems by the team for this project of Texas Research Institute, Iowa State University's Center for Non-Destructive Valuation, and Avid Research and Development for several NASA and Department of War needs. Previous efforts by the research team have developed systems with many useful features, such as producing high-resolution images in 3 dimensions, rendering 3-dimensional images of objects, which allows for real-time operation using 1D or 2D arrays, with fast high-frequency electronic components operating at relatively high frequency ranges, where antennas and other system components are small enough to render systems handheld or easily portable. The availability of commercial off-the-shelf technologies needed to build these systems, and the availability of already developed and rigorously tested SAR imaging algorithms required for the overall image production. In this project, we have produced an electromagnetic imaging system that is capable of inspecting through the coatings of interest to the Navy, again on the order of several inches thick. This prototype is in the process of being developed on specimens and items of interest to the Navy. This technology can be tailored to a number of different frequencies to address issues such as the one for this SBIR inspection, the thick polymer coatings and corrosion underneath paint, and everything in between. The project team understands the cost the sustainment of existing weapon system have in terms of both time and money for the Navy. The team is highly motivated to find other targets that benefit from this technology. Please feel free to contact us with regards to this and any other questions that you might have regarding our technologies. Thank you very much. We appreciate your time.